everyone. It is time for our last nuclear video. This is nuclear video 3. We're going to talk about the benefits and risks of nuclear chemistry. So we're going to go to our packet page 9. So packet page 9 at the top is already filled out for you. We talked about fission and fusion, their similarities and their differences. And here we're going to talk about the radioactive isotopes, their uses and dangers. So there are actually many beneficial uses of nuclear chemistry and radioactive isotopes. Everybody always thinks radioactive, and so they start thinking it must be bad, but it is not always bad. So there's a few things that are important. So one thing that everybody always remembers from earth science is if I asked you what we used for dating things, many of you would tell me that that is carbon-14. So carbon-14 dates once living things. So once living things. And actually, on my next slide, I have that carbon cycle. So what happens is I have things that were living and then they die or I bury them. So things like wood and bones. What happens is they have carbon-14 in them, but remember carbon-14 has a half-life that I could look up on table N, and I know that it decays by beta. So what happens is I have a carbon-14 and then a beta decay. And I'm going to turn into a nitrogen-14. So if I were to write that, it'd be carbon-14, which has 6 is its atomic number, a beta decay, 0 minus 1e. I'm getting 14 on top, and I'm getting 7 nitrogen on the bottom. So there's my beta decay. That's constantly happening. Carbon has a very kind of long half-life. It's about 5,715, I believe. But that will help me date things that were once living. As far as dating things that were not living, I can use uranium. But it's uranium-238. There's a lot of different uraniums. So uranium-238 is going to date rocks, so any rock formations that we have. So dating is one very beneficial use of our radioactive isotopes. I can also use this in industry. So think factories, things like that, industry. One thing that they can do, and I'll show you a picture in a second, is I can use radioactive isotopes to measure thickness. So I can use it to measure thickness. Basically, what I'm going to want to do is I'm going to see how much radiation is absorbed. Squeeze that in there. And one process that you might, well, you're not familiar with the process, but you're familiar with this. Oh, my picture's a little fuzzy, but what I'm looking at here is basically I'm making aluminum foil. We're making aluminum foil. So what happens is, and again, sorry if it's blurry for you, but we send the aluminum foil through, and there's these rollers. They're going to basically want to detect its thickness. And what I do is I shoot these beta particles at the foil. And remember that we know alpha particles are stopped by a sheet of paper. Beta particles are stopped by something a little bit thicker. So basically they're measuring how much of those beta particles are getting through. So they send it through, and they measure it, and nothing's wrong with the aluminum foil. Boom, they get the right thickness, and they're ready to go. Another thing I wanted to show you, we're not necessarily going to write this one down in our notes, but alpha decay in your smoke detector. Everybody at home has a smoke detector, or you should. And basically, this is how they work. We take AM-241, americium, and what happens is it goes through its half-life and it decays to neptunium. So, and you can see in our picture, our radioactive source is kind of right in that middle. So should you be scared that you have something radioactive in your house? Nope, you shouldn't be scared at all. But what happens is the clean air doesn't set off anything in the smoke detector, but as soon as it has smoke in it, it does set it off. So basically, this is another example of using nuclear radioactive isotopes to do something that's very beneficial. Also, I don't have a picture of this one. I should, but we can think of these as being chemical tracers. So they kind of follow the path of something. Okay? So I could use it as a chemical tracer. It shows the path. So it shows where things go. So, for instance, my stepfather owns a fertilizer company, and if I use phosphorus 31, I can put that in my fertilizer, and when I put it in there, I can monitor based on how much of that fertilizer does the plant take in. So basically, I'm going to follow that through my plant, and I'm going to see, is that fertilizer working? And that's one of the uses. I can also use, in my own body, I could use carbon-14, which they do that to kind of trace your metabolic processes. There's anything that they tell you to, you have to drink what's called charcoal. It's black. It doesn't taste very good, but it's carbon. And what they're going to do, they're going to kind of follow that through your body to see where your body's processing it. And the last ones we will write down will be our kind of medicinal uses. I'm going to put up this screen that I have here. So basically, radiation can be very harmful because it does damage cells and kind of changes the DNA, which often causes cancer. But it also can be something that helps me because some radioactive isotopes, they're useful, they date old objects, they image body organs, so you can see in A and B I have images of a thyroid gland and of a brain. And I'm going to look at those organs and tissues. That happens through x-rays, okay, or if you've ever had an MRI done. And then they also are beneficial in that they also can kill cancer cells. So what's interesting is that we have radioisotopes that can both cause cancer and help to cure cancer, which is very interesting. So it's important when I do medicinal things that I'm checking my half-life. I don't want things that are going to have very long half-lives, because if they're very long, well, then they're going to stay in your body for a long time. So I want something that's going to be pretty quick acting, that will just damage the cancerous cells that I don't want, and will leave my other cells alone. So that's why someone can't constantly have chemotherapy or constantly have radiation, because if they constantly had it, well, we would just kill them anyway. So what happens is they do targeted doses to try and get the cancer that is there. I was able to look at a lot of this with my mom. Some of you know my mom passed away, but it was of cancer. And so one thing that was very interesting is I got to look at the scans, and I got to see kind of what worked and what didn't. And one of the ones we're going to write down that they use in cancer scans is technetium-99. And you can see that it looks different when you look at a scan of somebody's organ that is infected. So let's write down the interesting ones that we have. So right here, our last one are medicinal uses. And actually, there's a few that we really need to know. So our medicinal uses, I'm going to go right here. So our first one we can have is, I showed you a picture of the thyroid. So iodine 131, that is used for the thyroid. It attacks and both treats. Thyroid detection and treatment. So they might use that to see if you have a problem with your thyroid, and then maybe give you more if they want to get something bad that they want to get rid of. Second, I said that my mom's scans use technetium-99 for the cancer scan. So, cancer scans. So that's really just to find it. And then if I want to target it to actually like kill the cancer, right, to shrink the cells that are bad, I'm actually going to use cobalt-60. So cobalt-60 is used to kill the cancer as best that it can. When they use those radioactive isotopes medicinally, remember that they're kind of weighing the benefits and the risks. So there is a risk that we're giving them something that's radioactive. But the benefit is, if I can make someone live a little bit longer, well, then it might be worth it. And the last kind of medicinal use, you might not think of it as just medicine, but they can use cesium-137, CS-137, and what they'll do is they'll kill bacteria in food with that. So they'll kind of send your food down a belt. They'll hit it with the cesium-137. You might see this if you ever look at meat that says it has been irradiated. If it's been irradiated, well, that means it's gone through this process and they've killed any bacteria. So if I look at this list, there is a list of a lot of things that are actually very beneficial. So I can date things. I know how old they are. I want to know maybe once living things, but I also might want to know rocks. So uranium-238 does the rocks. I can use it in industry, looking to see the thickness of things, how much radiation it absorbs. I can use it as a chemical tracer to kind of follow the path of something. And I have 4 different medicinal uses. Iodine 131 for thyroid, technetium-99 for a cancer scan, cobalt-60 to kill the cancer, and cesium-137 to kill the bacteria in food. So all of those things are great. But there are also risks. Right? There are also risks to using radioactivity. If we could just use radioactive isotopes and they were only good, that would be awesome. But they're not always good. So I'll kind of put it, I'm going to talk for a second, so I'll put it on my slide here. But first, the bigger picture, the clouds behind it, that's basically the picture of a nuclear reactor. So that's one beneficial use, is I can use it for power, which we didn't even write down, but I figure you guys know that I can use that to make nuclear power. But then I see the second big picture that's all in red, and that's the picture of a nuclear bomb going off. That is the mushroom cloud that you get when you set off a nuclear weapon. That would also be what you might see if a nuclear reactor were to fully melt down. Now, hopefully they don't explode when it melts down, but that is possible. So basically I have a beneficial use, but I also have something that would be a little bit scary in using it as far as a nuclear weapon, or if my power plant melts down. So basically, I could have an accident. I could accidentally set off a nuclear weapon. I could accidentally melt down a nuclear reactor. And then I see in the bottom, I see that caution radioactive. That's the, across the countries, that is the symbol for radioactivity. If you see that, you want to use caution. And we know that what I just said from before is that it could also, right, I use it for cancer, but it could also cause cancer. It could cause illness. It could cause death. If you have too much radiation, basically, that's always going to be very bad. And then also, even if my nuclear power plant doesn't melt down, I might have a hard time with the waste because it's really hard to store. It's really hard to dispose of. So that's something that's always definitely an issue for us when we're thinking of using anything nuclear. So let's write down some of those. So the risks, we said that we can have nuclear accidents, whether that be at a nuclear reactor, if we either purposely set off a nuclear bomb or accidentally. Nuclear radioactive isotopes can cause illness. It can cause cancer, even though it also helps it. And it can cause death. You can die from too much radiation. In fact, often, that's one of the things that leads to people dying when they use it for cancer and things like that. And my nuclear power plants are going to make nuclear waste. What are we going to do with that waste? Where are we going to put it? Because it's very hard to dispose of. It's hard to dispose of and to store it. These things have to sit for a very, very, very long time. And I've got to make sure that it's secure all of that time. One thing that I mentioned verbally, but I do want to put it into our notes, that for our medicinal uses, we always want to make sure that they are always things that have very short half-lives. And basically, they're going to have very quick elimination. Quick elimination from the body. That's important. We don't want it to stay. So if you look at the list, we know that we can use it for nuclear power. I told you over and over in class how much energy it creates. I could use it for many, many, many things, including medicinal uses that help us to live longer. But the risks are that you could have accidents. A nuclear reactor could melt down. It could cause illness. It could cause cancer. It could cause death. And where the heck are we going to store these? So when we're making decisions about nuclear chemistry, we need to be thinking about both the kind of the good and the evil, I call it, the benefits and the risks. So I want to thank you guys for watching this video. This is your last flipped classroom video. We'll do problems in class tomorrow. You did a great job so far this year. Thank you and see you tomorrow.